Again, this session, just to make sure for everybody else that this is by a request from one of your classmates. And the question was basically how to tackle these labs in general. Just give you the bottom line. Forget about all of this ins and everything else. I just want to get going, do my lab, and get out of here. Okay, that is because of the fact that we are online, and sometimes it gets a little bit confusing, and the wording is kind of verbose, too many words in this instruction. Does this sound right?
Yes.
Okay, so let me open the file first, and then I will share it with you, since the question was more on lab 2, but it actually works for any lab, as a matter of fact, so that you want to come in and do your lab and basically get out of here. Okay, so let me open the lab, and let me make sure I can see it, and then let me come in here to the Zoom session and share the screen with you. Oops. Share. Alicia, do you see the screen? Yes, your sound is out, so I can't hear what you're saying. You can leave the sound on if you want to.
I do. Sorry about that.
You see it?
Yes.
Okay, very good. So basically, this is the lab instructions. Like I said, lab instructions, especially the way I had them, was actually for in-class sessions, and I'm modifying them, so they tend to be a lot of words. So if we are sitting together, we would really go through these things and discuss them and do all of these things. Here is, in a nutshell, what you probably should do. The first thing I would start with is those questions. Those questions are actually guides to help you move through the concepts, and that's basically one of the things. So instead of reading the background, and probably it sounds a little bit too much, so I go straight to the questions and see if I can answer those. Now, from now on, Alicia and everybody else, please ask those questions. I don't want these questions to stay outside of the lab sessions. In other words, we answer them and we're done with them. So in question here, what is a scalar and what is a vector? How are they alike and they're different? A scalar is a number, basically, like the temperature. A vector is a quantity that has direction and magnitude. That's basically what the definitions are. A case, for example, of a vector is like velocity is a vector, force is a vector, and so on and so forth. A resultant is the vector sum of two vectors or more. Okay, that's what the resultant is. Okay.
Okay.
Does the resultant consider direction? Yes. So it's not just the magnitude. So if somebody is traveling 5 miles per hour and the car is moving 5 miles, or let's say, for example, an object is moving 5 miles per hour and something else is moving 5 miles per hour, and I want to add these two vectors, it matters which direction they are moving. The sum could be 10 if they are moving in the same direction, or it could be 0 if they are moving opposite direction, or anywhere between 0 and 10. If they have an angle between them. So the direction matters. So that's basically an answer to that question. So again, I'm just trying to help you guys in here so that you know where to start from. This is where you research. And from now on, when we do the lab, when we are meeting on Thursday at 6 p.m., we should answer all of the questions. We should not leave them for you guys to research them. So basically, we should do that. Does this sound like a better plan?
Yes, yes.
Okay. So question 3, again, did the computer calculate the resultant? Did you also perform? So in other words, in here, I really have to do the activity before. So in this activity in here, it's asking me to add this vector, for example, of 100 magnitude, of a direction 0, 0 degrees, that is, and another vector of 50 degrees, and a direction is 80. If I look at the table where it's asking me these things, here is the table. 100 at 0, 50 at 80, the sum should be 119. That's the vector sum, and the angle between them should be 24 degrees. Let's go back in here. It's giving me 119.3, which is good enough, which is 119. Remember, I'm not retaining more decimal points. And 24.4, which is approximately 4. So the answer to this one, at least from this exercise, is correct. Let's do another one in here just to satisfy our curiosity. 100 degrees at 0 degrees and 100 grams at 0 degrees and 100 grams at 90 degrees. This is a right angle triangle, okay, because both sides are the same.
Yes.
And according to the Pythagorean theorem, it should be equal to square root of 100 squared plus 100 squared, which is square root of 2 times 100, which should be 141. So, and it should make an angle of 45 degrees. That's basically what this is, because it's right angle triangle. So the other one is 100, and the direction is 90 degrees, perpendicular to the first one. So this is what that means, okay? So it's 141 as it should be. Square root of 2 is 1.41 times 100, so it's 141, 45 degrees as it should be, because again, it's not only a right angle triangle, but both sides are equal. So it's because both sides are 100 degrees, so the angle inside should be 45 degrees. So the answer to this question, yes, it seems like the computer is giving me the sums, and I can list at least these two examples to satisfy my curiosity. Did it also perform the graphical method for your hint? Now, the second part of this question, and I'm sorry I didn't really do it there, is you cannot really answer this one unless you really have the Excel spreadsheet. One of you guys asked for the Excel spreadsheet, and I sent it to her, and they really didn't really, you don't really need the second part of this question, okay?
Okay.
So now all of these activities, if we're going to do them, they will be online, and all of them, they will have a link to the GeoGebra account that I have for you guys. So that is where you focus on. Forget about everything else. Look at the steps in here, what he's asking you to do. In here, there is no steps. Basically, it's asking you to do all of these things. It tells you to go to this link. So we should go to this link. Before I do that, let's try to answer the other questions. Of the three methods, which one did you find easier? Again, this is a matter of basically your choice, because you have four methods. This is the graphical method. This is the computer sum. This is using that program, that software. And this is the equilibrium basically method in the class. And this is just the complement of that. Out of these four, which one you find easier? There is no right or wrong answer to this question. Okay, it's a matter of your liking. Some people like the graphical method. Some people are like, okay, just give me the numbers, I'll plug them on a calculator and give them the answers to you. So they're like the computer sum. Other people, they are more hands-on and they like actually to experiment with masses. So they like the other one. But try to give it justifications of why is this easier than the other one. For example, in terms of time, which one took less time to do? For example, in terms of visualization, which one is easier to understand than the other? So that's basically why this question is an open-ended question, and there is no right or wrong to it, okay? As long as you can justify your answer, okay? And the same token, using the same rules, which one was harder than the others? It's up to you, basically. Besides force, what other quantities, like vectors, which quantities add like scalars? I already gave an example with temperature as a scalar, as I gave an example with the force as being another example. And in here, actually, it asks you, besides force, the velocity actually is a vector. Other quantities that we probably you have seen already in physics 10 that are scalars and vectors. Mass, for example, is a scalar, okay? Mass does not have direction. So those are some of the terms that I could put in there. Pressure actually is a scalar also, although it involves the force over area, but it's the force exerted from all sides. Okay. Can you add the velocity vector to displacement vector? Of course, no, because you can't mix and match. That's a mismatch of units. Vector velocity can only be added to vector velocity. Displacement vector can only be added to the displacement vector, and that's it. Why or why not? The reason why not is because of the mismatch of units. I mean, how can you add 2 meters per second to 5 meters? They don't match at all. It's like asking, for example, to add $2 to, I don't know, to oranges. They're completely $2, have nothing to do with 2 oranges. I mean, or asking, yeah, these are mismatch, basically, things. That's the reason why. It's because of they are different quantities. You cannot add them together. So that's basically, in a nutshell, the questions. Let's go to the GeoGebra activity. That's where really the hardest part of this labs is in terms of work. But when we go, let me stop sharing that screen and go to the activity that popped up. Okay, that is where I'm trying to give you a feel of what these labs are. Basically, if tomorrow they say, okay, everybody goes home, goes to the lab, you're going to go and have instruction back in the classroom. So in this case, you're walking into the lab room, you see this apparatus, you know exactly what this is. This is for the force table experiment. You know exactly what that is, and you know also more or less how to operate it. Your hands are kind of rusty a little bit because you didn't do it by hand. But actually, in terms of operation, that's exactly what it is. That's what I'm trying to do. Mimic the actual thing that you would do in classroom. So, in here, remember we have a table, and we're guided now by the table, the one that we did with the components. Do you remember? You could do this sums with the vector with the calculator. Basically, I did only 2, but you could finish the rest, can't you?
I think so.
Okay. I don't like this. I think so. Okay. I like to do them all. Okay. Let's go back. Okay. It's a 50-50 answer is okay. Let's stop this and do the other one. Make sure that you're comfortable with this lab in and out. Okay. Okay. Am I sharing the screen now for the
Yes, I
table?
see it.
For the
Yes.
okay. So we did two. Remember, we did the. Let's go back to the table. I should have. So we did the first one, which is the example. We did this one. Let's do the 50 grams at 50 degrees, 100 grams at 165 degrees. Remember here we put 141, and here we put 45, okay, correct? That's what the calculator gave us. So I need the magnitude now from this, and I need also the direction from this. 50 grams at 50 degrees. Let's go up and put 50 grams at 50 degrees. 50 grams at 50 degrees. That's one. That's not completely everything, okay? So I need to go back in here and find where the other one, 100 grams at 165 degrees. Okay, 100 grams, that's already there, at 165 degrees, 165 degrees, correct? So the sum is 91 grams. That's the vector sum. So 50 plus 100, somebody might be tempted to say 150. That is not 150 because direction matters. It's 91 actually, less than the biggest one, because they are actually in opposite directions. 165 is more than 90 degrees. So, and the angle is 135 degrees between them. So let's go back in here and put 91 and 135, correct?
Yes.
So we're done with this part in here. Let's do this one, 100 and 240. Can you help me do this one?
Yes.
What should I put in here?
You would put 100 there.
Okay. And the angle?
Got 240. Was that what it was?
Okay. You need to look at the data.
Oh, give me 1 second.
Yes.
Hold on. Can you show it on your screen again? I'm sorry.
Okay. Okay. Here is the numbers.
It was a 0. I'm sorry.
Okay. Take a note of of all of these things. Okay.
Sorry.
Okay. So the second one, so it's 100 and 0. So I put 0 in here. The second one is 100. And what's the angle?
100, and then the direction in degree was 240.
240.
Yes.
So this is giving me 99.8, which is 100. And 299 or 300 degrees. Do I believe that? I guess.
Maybe.
99.8. Well, it's 99.8. I don't know. I mean, it looks right. But this is 300 definitely. Okay. So, yeah. Okay. So it is what it is. 240 degrees is almost. Wow. I don't know. I'm kind of confused. Let me get the Excel spreadsheet to confirm that. Okay.
Okay.
Oops. Okay, let me stop sharing that so that we get the same screen in here and share with you the Excel spreadsheet, the one that is in the instructions. So 100 and 0, and this one is 100 and 240.
Yes.
And this is 0. The vector C is 0. And vector, yep, 100 is the sum. 300 is, so that's correct. Okay.
Yeah.
So let's go back. Unless we made a mistake, hold on. Let me stop sharing that screen. Let me go back to the PDF file. Okay. The first one is 100. Yeah. So here is the 100. And here is 300 degrees. Okay. This one. 100, 0, 50, 60, 100, 180. Ready?
Yes.
Okay. What should I put in here?
100.
Here.
0.
Here.
50.
50. Here.
60.
Is it 60 or 160?
It's 60. 60.
Okay, what's this one?
It is 100.
Okay, and this one?
And 180.
180. Okay, it's giving me 50 and 60. Okay?
Okay.
I'm ignoring the decimal points because if I probably do it more accurately, so just 50 and 60. Okay? This makes sense because 100 is 0 degrees, 180 degrees, they cancel one another. So the one that stays is the one in the bottom,
Yeah.
between. Okay, the last one, 100 and 0, 50, 160, 100 and 215. This is a big one. So you have them ready?
I do.
Okay. So the first one is
100.
okay.
I'm sorry, to 100. 0. That's right.
Okay.
And then 50. 160.
160.
Yes, 160.
100
and then the other one's 215.
The degrees is 215 degrees. Okay, so it's giving me 50 or 49 and 234 degrees. 59. No. What is it again? 49 and 240 degrees, or what was the angle in here? Let me go back to it. 234 degrees. 234. Okay. 234 degrees. Okay. So that's basically in a nutshell all of this. Okay. So we have done this now. Now we're ready to go to this equilibrant in here. Okay. You said, remember the, oh, I'm sorry. This is I put them in the wrong fields. Okay. All of these numbers should be shifted in here. Okay.
In the computer sum, correct?
Yeah. And the computer sum, you should have picked it up on.
Yeah.
That's your job. So this is 100, 300, and this is 50, 60. Okay. And this is 49, 234. Okay. So that was too much in here. This is reserved for later on when you do actually the vector sum, okay?
Yeah.
With the ruler and, okay. This is how the table should look like by now. So now we're going to defer this ones in here. The magnitude, we should get it from here. Now, when the resultant is 141, so I cannot do 141. So I probably will try 140. This is try, not necessarily correct, okay? And add 180 to 241, so it's going to be 225 degrees, okay?
Okay.
So that's the opposite. So I'm going to add 100, 100, and one at 90, and the equilibrant should be 140 because remember we have increments of only 10 grams in the actual lab, and it's going to be opposite to where the resultant is. So if the resultant is 45 degrees, I add 180 to find where the equilibrant is. So let's go back into GeoGebra now. Let's stop sharing the screen and take that data with us to GeoGebra. Okay, where is GeoGebra? Here it is. So we said 100 and 0. What was the other value in here? The other vector, 190, 190. And we predicted the sum to be 140 because we can do 141. Okay? That's the equilibriant. And the direction, the sum was 45 degrees. We added for 180 degrees to it. So it's going to be 225 degrees. And the ring is free. That means we really have equilibrium. Correct?
Yes.
So this part is fine. So let's go back into stop sharing the screen and go back into the other screen with the with this vectors in here. So the data need to stay it is. The sum in here, it cannot be 91. It has to be 90. The direction is add 180 degrees to 135. If I add 135 plus 180, this calculator is giving me 315 degrees, okay? So 315 degrees, it's still within the circle. So it's 315 degrees, 315 degrees, okay? So I added 180 to it. Let's see here, okay? Let's see here if it works. So I'm gonna stop in here. So it's 315. So let's go and share the screen in here and go back into here. So what was the vectors though? 100, was it 50 somewhere?
Yes.
Which one is 50? Which one is? Okay, so the vector is 50, 50, and 100, 165.
Yes.
Okay, so which screen I'm sharing now? Okay, let me share the screen then. So this is 50. Direction is 50. And this is 100, and the angle is 165 or 160?
165.
165. The sum turned out to be 90, and the direction is 315.
Yes.
Okay, bearing is free, so it works. Okay, correct?
Yes, it does.
So that's what you actually do in the lab. You adjust it so that it works. Of course, you will have to, most of the time, even if I put 314, it's probably going to work, okay? So that still works, okay? So any of this data should work. Because if there is friction, that's why there is the ring doesn't really move that much by moving it slightly above. And whichever value I put in there is fine, okay? So by the way, you can put either one of these two. Okay. In here, the sum is 100. So I'm going to leave 100. So I'm not going to play with this one. And the direction, I add 180 to 350. That should be 480 degrees. Correct? I cannot go more than 360. So instead of adding the 180, I'm going to subtract 180 from 320. So 300 minus 180. Remember, I have to stay within 360. So the answer is 120 degrees. Okay?
Mm-hmm.
So either add or subtract. That's basically put it on the opposite side. It doesn't matter. Okay?
Yes.
So it's 300. I'm going to go back to 120 to opposite it. So it's 100 and 0 and 100 and 240. So let's stop sharing this screen and go back into the other screen. So it's 100 at 0. And this one is what? What was the second one?
50.
50 at what angle?
60.
60. 60 or 160?
60.
60. So the sum of the two was how much? 100?
Yes.
That doesn't make sense. Okay, well, it makes... And the direction was 120?
Yes.
No, there's something wrong with this one in here. Oh no, there is no 50 in there. It's 100, 100.
I'm sorry, yes it is.
That's fine. So this is 100. And for some reason, I'm not...
Was the direction 240?
Was it 240? Yeah, okay.
Yeah, 240. Yeah.
Okay, so now it's better, okay?
Yeah, sorry.
Okay, yeah, okay. So even if I put 122, for example, it should work, okay? Like I said, because there is a friction in here element. Okay, let's do at least one more. Do you mind?
No, that's fine.
Okay, this one should be easy, okay? Because 50 and 60, I add 180 to 60, should be 240, so this should work fine, okay? So I probably will predict it right now to be 50, and 160 plus, that's 240, so this should work, okay? Provided I put all of the three numbers in here plus this, so it's going to be 4. Let's try this one now, which is a little bit different. So the sum is going to be 50. I cannot put 49 in there, remember?
Mm-hmm.
And the angle is 234. If I add to it 180, so it's going to be 400 and something, actually. 234 plus 180 should be 414. That again puts me outside of the 360. So I need to subtract actually from the 230 180. So now I need to subtract to go in the opposite direction. So it's going to be 54 degrees. Okay. 54 degrees. Are you looking at the Excel spreadsheet? I mean the PDF file, or still on the data?
I'm still looking at the force table. I don't know if you were sharing.
Okay. So let me stop sharing that screen and share with you the PDF so that to show you how this is shaping up right now. So this is the value. So 49 was the sum. I cannot do 49. I have to do 50. If I add 180 to 234, it's going to put it outside of 360. So I'm going to subtract instead, which is put it between 0 and 360, which is the answer is 54. So 100 at 0 degrees, 50 at 160, 100 at 215, and the equilibrium is 50 at 54 degrees. Let's try that. Okay, I'm going to stop sharing that screen and now go into the force table. Can you help me in here? What was the first one? 100 at 0 degrees?
At 0 degrees.
The second one?
50.
At what direction?
At 160, 160.
160. And this one?
100.
215. 215. And the resultant was 50.
At
I mean,
54.
50. And the equilibrium was at 54. The resultant was at 200 and something, okay?
Mm-hmm.
Okay, again, it works, okay? If I put 50, let's try to put 50 in here, degrees, no equilibrium. If I put 51 degrees, if I move it slightly this way or the other, it's going to not work, okay? How about 53 degrees? It's still not working. And this is sensitive, that it's probably going to work with 54. Let me try it with 55. 55 still works. 56 degrees still work. No,
No.
either 50 or 55,
Yeah.
54 or 55. Okay, either one of these values is fine. So stop sharing that screen. Okay, and go back into my PDF file. So in here I could put 55 if you like. Either one would work. So now I go in here. This value is exactly as I found it from here, not from this computer sum. It's from here. So the magnitudes should transpose exactly as they are. It's 140, 90 grams, 100 grams, 50 grams, and 50 grams. Correct?
Yes.
Here the direction I need to subtract or add 150 back to what I was. This was 45. This was 135. This is 300. This is, what is it, 60. And this actually now it's not 234 but 235, which is the same thing. Okay, so all of this works. Now the last part of this lab now is to actually do the drawing.
Okay.
So basically grab a ruler, okay, and protractor and start going through the x-axis, go the direction you want to go with, and then with the ruler based on your scale, as I showed you with the picture that is in the lab instructions, you should be able to do the rest of them and append the pictures.
Yes, and then that's when you told us to, we would have to download GIMP, right? GIMP?
You don't have to. You don't have to.
Okay.
I mean, that is just to make the picture go faster when you upload it. Because sometimes when I'm grading these things, it takes a long time for me to load somebody else's assignment because it's seeing behind the scene that there is a big file. So it takes a long time for the canvas to load the image in front of me to be able to look at it. So just as if you that's to make the file look smaller actually than to optimize it. You don't have to. If you can set your phone while you're taking the picture, change it from the high resolution phone to a lower resolution, such as web resolution, or I think they call it video resolution or TV resolution, whatever lower resolution that the lowest resolution your phone can go is great. Okay.
Yes.
That should work. Okay. When you
Okay.
take the picture, that way the picture loads faster. You don't have to do GIMP. I don't want you to waste too much time on this, especially if you have never used GIMP. It's very hard to learn. There is a big learning curve on it, so I don't want you to do that. Just I showed you one way of making it faster, because for me, I have a problem. I don't know how to figure out my iPhone. That's why I use GIMP. Okay?
Okay. Okay, perfect.
So as long as the image looks fine, I mean to you, if you can lower the resolution, that would be great. If not, just upload the thing. Okay, put it on. Okay?
Okay. Okay. That was clear, actually.
Okay. So is there any other, okay, from now on, when you guys receive an assignment, like for the labs, the first thing is, first of all, we're going to stay in here. I stay with you until 9:10 p.m. Like last time, for example, after that, we go for about an hour session to discussing these things. And then some of you chose to stay behind. I stayed with them. And you guys ask questions, because that's the lab when you're supposed to be doing it, actually doing the hard part of it. The reporting is later on. And answer all of the questions. We go through all of the questions, answer them, and then go through the activities and try to understand them. And now formulate your own, in your own wording, the answers to the questions. You still have two lingering issues that you need to have in there. First of all, based on the activities, what is it do you think we wanted to achieve for this specific lab? For example, we wanted to learn how to add forces, how to add vectors, how to add vectors to add forces and velocities and things like that. So that's basically what we're doing. We're exploring three methods that's still in the objective. We're exploring the graphical method. We're exploring also the computer, basically a calculated method. And we're using also the third method, which is the force table, which is an experimental approach. All of these threes, of course, they should give us the same result. Now, that's what we're saying. We're exploring three methods. This is in the objective. Now we go back into the conclusion. Based on the observations that we have, we explore three methods to calculate the sum of different vectors using the force table, using this approach, which is the computer sum, and using the graphical method. Based on our observations, all the three methods, there is either congruence, they agree, or they don't agree. If they don't agree, or if they agree, in this case, probably you don't have numbers, but down the road, you should have numbers to support your conclusion. If they agree with what percentage of error they agree, if they don't agree because you lack, for example, there is a big difference in the error, then there is, at least you can say they don't agree. You don't have to necessarily agree with what is assumed to be a hypothesis. Your conclusion may differ from what you think is correct. So basically, that's what the conclusion is. Those are also graded, the conclusion and the objective, and that's it. That's basically how your labs are structured. Okay?
Yes, thank you very much.
No problem. I'll see you tomorrow. No, is it tomorrow? Thursday.
Thursday.
Okay? Okay.
Thank
And
you.
if you have any questions, please ask them. Okay, and I'll post this one later on in the discussion forum. Thank
Okay.
you.
Thank you very
Bye.
much. Appreciate it.
Bye.